Alright, today we are going to continue talking about combinations of functions and composing functions, which we're going to actually get to today. Alright, so the composition of functions. It says the composition of the function f with g is denoted by f of g, that's called, and it is defined by the equation f of g of x equals f of g of x. That's how that's read. So if you're given a numerical value of x, like they want you to find f of g of some number, substitute the numerical value for all the x's in the g function and simplify. Then substitute that answer into the x's in the f function and simplify that. So it says your function f is 3x plus 2 and your function g is 2x minus 5. So they want me to find f of g of negative 4 and g of f of negative 4. To find f of g of negative 4, I go to the g function, which is this one. I take out his x and I replace it with negative 4. And then when I simplify that, I get, this would be negative 8 minus 5 is negative 13. So then I take that answer and I'm going to put it into the f function. And the f function says take 3 times whatever you're bringing and add 2. I brought a negative 13, so I stick that in for x. And I simplify that, and I get negative 37. So we say f of g of negative 4 equals negative 37. And to find g of f of negative 4, now we're going to take negative 4 and plug it into the f function, and then take that answer and plug it into the g function. So when I take the f function and I plug in negative 4, I have 3 times negative 4. Again, I change his x to negative 4. That gives me negative 10. So I'm going to take that now and go to the g function, which says take 2 times what you brought and subtract 5. And that would give me negative 25. So g of f of negative 4 equals negative 25. That's compositions of functions numerically. Okay, so it says, here's your f function, 3 times whatever you brought minus 4, and here's your g function, which says, take whatever you brought, square it, multiply it by 2, subtract that, and add 6. So this one wants me to find g of f of 1. So to find g of f of 1, I've got to do the inside first. Okay, so I take 1 to the f function. The f function says 3 times whatever I brought minus 4. And I'm bringing a 1. So if I simplify that, I get 3 minus 4, which is negative 1. So f of 1 equals negative 1. So now if I plug that in here, I'm finding g of negative 1, which says take the g function, take out his x's, and plug in what you brought, and I'm bringing a negative 1. So negative 1 squared would be positive 1. Negative 2 times negative 1 would be positive 2, plus 6. That's going to give me 3 plus 6 is 9. So g of f of 1 equals 9. So now to find g of f of negative 2, again, g of f of negative 2, that means we're going to go to the f function and plug in negative 2. So the f function says 3 times what you brought minus 4. I'm bringing a negative 2, which gives me negative 6 minus 4, which is negative 10. So f of negative 2 equals negative 10. So if I plug that in there, that says g of negative 10, which says go take the g function, take out all of his x's, and plug in what you brought, which is negative 10. So if I square this, I get 100. Distribute that, I get 20. And that gives me 126. So g of f of negative 2 equals 126. Okay, if they give you more complicated functions, don't panic. They want me to find f of g of 2. So f of g of 2 says take 2 to the g function. The g function says whatever you brought minus 1. So I'm going to bring a 2. Simplify that. 2 minus 1 is 1. So g of 2 equals 1. So I'm going to plug that in there. And that says take 1 to the f function. And the f function says the square root of whatever you brought. And I brought a 1, and the square root of 1 is 1. So f of g of 2 equals 1. Okay? For D, I have a little story if this helps you remember. Think of it this way. D says we want to go to 2 parties tonight. We want to go to the G party and we want to go to the F party. But if we have to do G of F of 2, we have to party hop in order. Otherwise it's just rude. Alright, and this party hopper says you have to go to the F party first. And the F party says, man, at our party we got a square root going on. You bring us something, we'll take the square root of it and give it back to you. So I plug in 2. The square root of 2 is 1.4 something, 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 something. Alright, but we're just going to leave it a radical. So f of 2 equals the square root of 2. So if I replace this with the square root of 2, it's telling me to go to my second party. To go to G's party, you need to bring a square root of 2. Don't bring the 2. You already took that to the F party, played with it, and came out with a square root of 2. Now you're going to take that and go to the second party. And G's party says, take whatever you brought and subtract 1 from it. Well, what I'm bringing from the F party is the square root of 2. And I can't combine that, so I just leave it, square root of 2 minus 1. And I say G of F of 2 equals the square root of 2 minus 1. Okay? You try one, hit pause, come back when you're ready. And hopefully you got 66,969. Okay, this one wants me to find f of g of 8. So my party story, if you like that, says go party at G's house with an 8. Well, the G party says bring us what you got. I'll multiply by 9 and then subtract 9. And they told me to bring an 8 to the party. So that would give me 72 minus 9, which is 63. So G of 8 equals 63. So I'm going to plug that in there, and it says take what you're leaving the G party with and take it to the F party. The F party says 17 times whatever you brought squared minus 8 times whatever you brought. I brought a 63, so I plug that in. And you've got to square first, so 63 squared, enter, times 17 is this number, 67473. 8 times 63 is minus 504. 67473 minus 504, and you get 66969. So f of g of 8 equals 66,969. Okay? Alright, so now what if we compose functions but not with numbers, we do it with letters? They want us to find f of g of x. Well, really all you do, sorry I keep touching this, really all you do is this says f of g of x. If you go with the party story, this is saying take an x to the G party. Well, my G party already has an x in it. So taking out his x and putting an x back in means I'm going to leave with the same function. So basically you show up with G with an x and say, here, take my x, what can I have now? Alright? So you would take the G function and then plug it into the F function. Okay, so if I find f of g of x, this says take the G function and plug it into the F function. The F function says 3 times whatever you brought plus 2. Well, I brought the whole G function, the 2x minus 5. Yeah? So if I simplify that, I would get, can I animate this? Yeah. I'd get 6x minus 15 plus 2, which gives me 6x minus 13. So f of g of x gives me 6x minus 13. Now g of f of x says go get the f function and take it to the G party. The G party says 2 times whatever you brought minus 5. I brought the f function and plugged it in for the x. So if I simplify that, I get 6x plus, oops, I'm probably going to need it, 6x plus 4 minus 5. Combine like terms and you get 6x minus 1. So g of f of x equals 6x minus 1. Do you think these two would ever be the same? I don't know. I wonder what happens if it is. Okay, excluding values from the domain of the composition. It says the following values must be excluded from the input x. If x is not in the domain of G, it must not be in the domain of the composition. So whatever one is inside, you find that domain, and whatever that domain is, regardless of what ends up happening, it still has to be in the domain of the composition. So any x for which g of x is not in the domain of f must not be in the domain of the composition. Okay? So if you look at this example, okay, if I take f of g of x, and here's my f function and here's my g function, what that means is for my g function, x cannot equal 0. So 0 is not in the domain, therefore it's got to be excluded from the composition. And then you have to check the other one. You have to check the final one when you're done, and whatever that ends up with, you can't let that denominator equal 0 either. So you're going to get basically an overlap of restrictions. Okay, so it says given f of x equals 3x minus 4 and g of x equals x squared minus 2x plus 6, find each of the following. And then find the domain of each. Well, this says f of g of x. What that says is to take the g function to the f function. The f function says 3 times whatever you brought minus 4. And I'm bringing the g function. In other words, what does g of x equal? It equals x squared minus 2x plus 6. That's what g of x equals. So it's telling me to replace that x with x squared minus 2x plus 6. And simplify that. Distribute, I get 3x squared minus 6x plus 18 minus 4. Combine like terms, I get 3x squared minus 6x plus 14. So f of g of x equals 3x squared minus 6x plus 14. Now for my domain. You have to look at the g function first. The g function here, okay? So g of x has no restrictions. There's no denominators, no radicals, so g of x is all real numbers. The composition, this one, has no drama either. So its domain is all real numbers, and where these overlap, the domain of the whole composition is then all real numbers. So negative infinity to infinity. Okay, on the second one, they want me to find g of f of x, which this says g of f of x, which says g of the f function. The f function is 3x minus 4. So on g's function, which I'm going to need way more room, g of the f function says copy g, except for its x's, and everywhere you see an x, you're going to plug in what you brought, which is 3x minus 4. Now to simplify this one, it's going to be a little more complicated. To square that bino, you're going to have to make 2 copies. Distribute here, I'm going to get minus 6x plus 8 plus 6 drops. So to clean this up, I'm going to distribute. That's going to give me 9x squared minus 12x minus 12x plus 16 minus 6x plus 8 plus 6. Now I can combine like terms. I have negative 12x, and negative 6x, and then I have these constants, and then this squared term. So g of f of x equals 9x squared. That's negative 24, negative 6 is negative 30x. That's 16 plus 8 plus 6 is 30. And we've got to do domain again. Well, here now we've got to take the domain of the inside function. So the domain of f of x, there's no drama, so it's all real numbers. And then we have to find the domain of g of f of x, which there's no drama, no radicals, no denominators, it's all real numbers. So the domain of the function is going to be all real numbers, which is negative infinity to infinity. Alright, so now let's try this one. It says, given that f of x equals 2 over x minus 1 and g of x equals 3 over x, find each of the following. A, they want the composition, and B, they want the domain. Alright, so for A, they want me to find f of g of x, which means they want me to find f of 3 over x, because the g function is 3 over x. So I'm going to copy my f function, but instead of x, I'm going to put in what I brought, which is 3 over x. Okay? Now, to solve this, I need to get a common denominator, which is going to be x. This one already has a denominator of x, so leave it 3. This one, to get a denominator of x, I'd have to multiply by x on the top and the bottom, which is going to give me negative x over x. That's still 1. Now I can combine terms on the bottom, and I get 3 minus x over x. Now I have a complex fraction, so I can keep, change, flip. So I'm going to keep the 2, change to times, flip to x over 3 minus x, and that gives me 2x over 3 minus x. So there's my f of g of x. It is finally equal to 2x over 3 minus x. Okay, there's A. Now B, they want the domain of f of g. Well, first of all, I have to figure the domain of g of x, which would say x cannot be 0. Then I have to find the domain of f of g of x, which is down here, which says 3 minus x may never equal 0. So add x, and I'd get x can never equal, or 3 can never equal x. So, if I graph both of these, at 0 there's going to be a hole, and at 3 there's going to be a hole. And I can color everywhere in between, so my domain of the whole composition is going to be negative infinity to 0, union, 0 to 3, union, 3 to infinity. Okay? Alright, let's try another one. They want us to find f of g of x, which means they want me to find f of the g function, which is the square root of 1 minus x. So that says copy the f function and plug in what you brought, and I brought the square root of 1 minus x. If you square a square root, it kills it. Combine like terms, I get negative x plus 5. So f of g of x equals negative x plus 5. Domain. Okay, well first of all, since g is on the inside, I have to find the domain of g of x, which says, Mr. Radical, you must always stay positive. Square, square, I get 1 minus x has to stay greater than or equal to 0, minus 1. Negative x has to stay greater than or equal to negative 1. Divide by negative 1, which flips your inequality. X has to stay less than or equal to 1. So there's the domain of G. My domain of the composition is negative x minus 5. There's no drama there. There's no radicals. There's no denominators. So the domain of this is all real numbers. Okay, so that would color everything for the composition. Now, your domain of the actual composition is where these overlap. So, where they overlap is at this point and everything below. So, my domain of the whole function goes from negative infinity to 1. And it includes the 1, so I need a square bracket. Is it okay? Oops. Alright, so let's try this one. They want me to find f of g of x and g of f of x, then find the domain. Well, if I do f of g of x, that's telling me to take f of the g function, which is 2 over 3x, and they want me to plug that in for my x on f. So instead of x, I'm going to put 2 over 3x. I've got to get a common denominator, which is going to be 3x. So to get to 3x, I'm going to have to multiply by 3x, which gives me 18x, which then if I simplify, I have 5 over 18x plus 2 over 3x. And now if I keep, change, flip, this is straight across the top, f of g of x equals 15x over 18x plus 2. And no, you can't simplify the 15x and the 18x, unless you could divide everything by 2, but no. Okay, so there's my composition. The domain, since g was in the middle, I do the domain of g. Alright, that says that 3x may never equal 0, so x may never equal 0. I can do the domain of, well, I'll do that later. And then I need the domain of the composition, which says 18x plus 2, u may never equal 0, so 18x may never equal negative 2, so x may never equal negative 2 over 18, so x may never equal negative 1/9. So we have x cannot equal 0 and x cannot equal negative 1/9, which means my domain of the composition is negative infinity to negative 1/9, union negative 1/9 to 0, union 0 to infinity. That's way too big, and I'm going to run the rest. My domain of the whole thing would be negative infinity to negative 1/9, union negative 1/9 to 0, union 0 to infinity. I took up way too much room. Okay, so now to find g of f of x, they're really asking me to find g of the f function, which is 5 over x plus 6. If I copy g, that's going to be 2 over 3 times 5 over x plus 6. If I simplify that, I'm going to have 2 over 15 over x plus 6. Keep, change, flip. I end up with 2x plus 12 over 15. So g of f of x equals 2x plus 12 over 15. And for my domain, I've got to get the domain of f first. So the domain of f, my domain of f would say that x plus 6 can never equal 0, so x can never equal negative 6. The composition has no drama. Yes, there's a radical, but, there's a denominator, but there's no letter in it. So the domain of g of f is all real numbers. So I can be everything except for negative 6, which makes my domain negative infinity to negative 6, union negative 6 to infinity. Okay? You try this one, hit pause, come back when you're ready. And hopefully you got negative 6x plus 8. They want me to find g of f of x, which means they want me to find g of the f function. The f function is negative 2x plus 2. The g function says 3 times whatever you brought plus 2. I brought negative 2x plus 2. Distribute, I get negative 6x plus 6 plus 2, combine like terms, negative 6x plus 8. G of f of x equals negative 6x plus 8. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got 35x over 4 plus 40x. Alright, f of g of x really means find f of the g function. The g function is 4 over 5x. The f function says 7 over whatever you brought plus 8. And I brought 4 over 5x. So I've got to get a common denominator, which is going to be 5x, which makes this 40x over 5x plus 4 over 5x. That's going to give me 7 over 4 plus 40x over 5x. So now I'm going to keep, change, flip, multiply the tops, I get 35x over, keep the bottom, 4 plus 40x. That would be f of g of x. Okay. Try this one, hit pause, come back when you're ready. And hopefully you got negative infinity to negative 11 or negative 11 to infinity. They want me to find the domain of f of g of x. So they want me to find the domain of f of the g function. The f function says 10 over whatever you brought plus 7. And I brought x plus 4, which gives me 10 over x plus 11. Alright, so to find this, since g is on the inside, I need the domain of g, which would say there's no drama in g. There's no fraction, no radical, so that's all real numbers. Everything works. If I do my composition, the domain of f of g, and then where was I now? Oh, the function has this, which is going to say that, hold on, this is going to say that x plus 11 may never equal 0, so x may never equal negative 11. So you got this number line that has everything, but negative 11 I have to make a whole, which means my domain of the function goes from negative infinity to negative 11, union negative 11 to infinity. Yeah? Okay, you try this one, hit pause, come back when you're ready. And hopefully you got 0 to infinity. Alright, so if they want me to find f of g of x, they're asking me to find f of the g function, which says take a square root. And then I copy my f function, 3 parentheses plus 9, and I plug in what I brought, which is the square root of x, which gives me 3 square roots of x plus 9. That's what my f of g of x equals. But that's not what they asked for. They asked for the domain. Well, because g was inside, I got to find the domain of g, which says, Mr. Radical, you must always stay positive. Square, square, so x must always stay greater than or equal to 0. So there's the domain of g. My domain of f of g is going to be the same drama. There's a radical, so Mr. Radical, you must always stay greater than or equal to 0, square, and x always has to stay greater than or equal to 0. So we have the same domain for each, which says you can go from 0 to infinity. Alright, so now what if we have to decompose functions? In other words, you have to figure out what two functions they put together to get this new function h. It's really actually very simple. If you have something to a power, okay, the h can be expressed as the f function was x to the power, and g of x is whatever's inside. So if you look at my example, they're saying they composed a function and got this polynomial to the 5th power. All you have to do, guys, is whatever's inside, that's your x, or that's one of your functions. So f of x would be, take out all the junk on the inside, and it's just going to be x to the 5th. Okay? So then g of x would have to be taking the whatever that polynomial is. So g of x in this case would be 3x squared minus 4x plus 1. Yeah? And then if you took the composition f of g, you would plug this in for x, which gives you h. Okay? So it says express h of x as a composition of two functions. You can picture what's inside as f. So my f of x is going to be x squared plus 1. No. No. Yes. No. Yes. X squared plus 1. And then my g function is going to be the cube root of x. Because then if you did f of g of x, you would have the f function, which, no, backwards. I'm backwards. The f of x is, I'm backwards. The f of x is the power. So f of x is going to be the cube root of x. And the g is what you replace the x with, which is x squared plus 1. Sorry. And that's why you guys, you should always check. Okay, so this says plug this into the f function, which would be the cube root of x squared plus 1. So I'm right. Okay, so again, here, f of x would be the power. So that's going to be x to the 4th. And your g of x is what they put in for x, which is 3x minus 1. Okay, if we look at this one, the power is f. So my f of x would be the cube root of x. Your g of x is what's inside, which is going to be x squared minus 9. This is a power, kind of. It's absolute value. So my f of x is going to be the absolute value of just x, where g of x is what's inside that power, which is 2x minus 5. Alright, you try this one, hit pause, come back when you're ready. And hopefully you got 3. Okay, your power would be f of x, that would be x to the 7th. And your g of x is whatever's inside, which is 4x minus 19. Try this one, hit pause, come back when you're ready. And hopefully you got that. Your power is going to be the radical, and that's a power. So your f of x is going to be the square root of x. And your g is going to be what's inside, which is negative 36x squared plus 10. Okay? And we are... Oh no, I thought we were home. Okay, so it says a department store has 2 locations in a city. From 2008 through 2012, the profits for each of the store's 2 branches are modeled by the functions f and g. In each model, x represents the number of years after 2008, and f and g represent the profit in millions of dollars. Okay, A says, what is the slope of f? If you look at these functions, they're linear. They look like y equal mx plus b. So whatever's touching x is your slope. So the slope of f is negative 0.44. The slope of g is positive 0.51. It says find f plus g, and what is the slope of this function, and what does this mean? Okay, well, you're looking at the functions represent profit. So obviously f is losing profit and g is gaining profit. So what happens if we add f plus g? Well, I would take my f function, which is negative 0.44x plus 13.62, and I would add it to the g function, 0.51x plus 11.14, and then combine like terms. F plus g of x equals negative 0.44 plus 0.51. You get positive 0.07x. combine constants, 13.62 plus 11.14, you get plus 24.76. So the slope of the sum is 0.07. And what does this mean? It means that we are making money. If it was negative, it would mean we are losing money. Okay, it says the regular price of a pair of jeans is X dollars. Let f of x equals x minus 5 and g of x equals 0.6x. Describe what functions f and g model in terms of the price of jeans. Well, f says you're going to take the price and subtract 5. So for f of x, it means that you are going to take the price and you're going to reduce by 5. So you're going to be getting a $5 off the price. G of x says you're going to be 0.6x. If you make that a percent, what that means is you're going to be paying 60% of the price. Okay, that's what this means. 0.6 times x means 0.6 of the price, which means you're paying 60% of the total. Or you can look at it, which means you are saving 40%. Okay, so now B says find f of g of x. Well, to find f of g of x, this says take the g function and plug it in for f. So if I take the f function, that says whatever you brought minus 5. I'm bringing the g function, which is 0.6x. So my composition is 0.6x minus 5. What that means is you're taking, so you did this first, right? Okay, so you're taking 40% off. Then subtracting 5. So you're getting your 40% off, and then you're getting your $5 off. Okay? So now it says, C, repeat part B for g of f of x. If I do g of f of x, that says copy g, which is 0.6 times f, and my f is, change colors here, x minus 5. So what I would do there is, you're doing this first, which says you are subtracting 5 first. You're taking $5 off first. Then you're going to take off 40% of that. Okay, it says which composite functions models the greater discount on jeans, f of g or g of f? Well, I need more room. Let's pick a price for a pair of jeans and see which gives us the better savings. Let's say that our jeans were 50 bucks. If I follow f of g of x, I'm going to take of g of 50. That says take, well, if I just do it all in this, that's going to say 0.6 times 50 minus 5. So 0.6 times 50 minus 5 is going to be 25 bucks for the jeans. Okay, if I do g of f of 50, this says take 50, well the function says 0.6 times 50 minus x, or 5. So if I took 50 minus 5, that's only $45. That's taking the $5 off first. And then take 0.6 times 45 and you get 27. So if you take off the $5 first and then the percent, you pay 27. Where if you do the percent first, then take off 5, you pay 25. So which is the better deal? F of G. Okay. Alright, so how do you find the composition of functions using notation f of g of x? You plug in g of x for the x's in f of x and simplify. And give an example of a composition of functions in the real world. We just did one. We just did the genes problem. You could make up one of your own. Okay? Alright, and we are at homework, so we are done. Happy homeworking, and I will see you next time.